Hi everyone. Today we are going to apply the multiplication rule to a probability problem involving marbles. As we work through these questions, focus on the process rather than just the arithmetic. Ask yourself these questions. What event are we trying to find? Do all of the events need to occur? How does each selection change the probability of the next selection? Keeping those questions in mind will help you solve many probability problems. Let's get started. A jar contains 5 red marbles, 7 blue marbles, and 11 green marbles. A child randomly selects 3 marbles from the jar without replacement. Before we begin calculating anything, let's make sure we understand the picture. Notice that the jar contains marble of 3 different colors. The important phrase in the problem is without replacement. That means once the marble is selected, it is not returned to the jar. As a result, the probabilities will change after each draw. This means we are working with dependent events. First, let's determine the total number of marbles. There are 5 red, 7 blue, and 11 green marbles. So to find the total number of marbles, I take 5 plus 7 plus 11. That equals 23. So our jar contains 23 marbles altogether. We'll use this total repeatedly throughout this example. Question A. Find the probability that all 3 marbles are red. Let's think about what all 3 marbles are red means. That means the first marble must be red, and the second marble must be red, and the third marble must be red. Since all 3 events must occur, we use the multiplication rule. So the probability that all 3 marbles are red equals the probability that the first one is red times the probability that the second one is red and times the probability that the third one is red. Now, let's calculate each probability. First, I want to find the probability that the first marble is red. There are a total of 23 marbles and 5 red marbles. So the probability that the first one is red is 5 out of 23. If the first marble was red and not replaced, there are now only 4 red marbles remaining out of 22 total marbles. So the probability that the second one is a red is 4 out of 22. After removing another red marble, there are now 3 red marbles remaining out of 21 total marbles. So the probability that the third marble is red is 3 out of 21. Now we multiply them. 5 times 4 times 3 is 60. 23 times 22 times 21 is 10,626. So we have 60 over 10,626. And the question is asking for 4 decimal places. So we take 60 divided by 10,626. And the answer is 0.0056. Now that we have calculated the probability of drawing 3 red marbles, let's repeat the same process for blue marbles. Notice that the procedure stays the same, only the numbers change. Question B. Find the probability that all 3 marbles are blue. So I want the first one blue, and the second one blue, and the third one blue. There are 7 blue marbles out of 23 total marbles. So the probability that the first marble is blue is 7 out of 23. If the first marble was blue and not replaced, there are now 6 blue marbles remaining out of 22 total marbles. So the probability of the second marble is blue is 6 over 22. And after the second blue marble was removed, there are now 5 blue marbles remaining out of 21 total marbles. So the probability that the third marble is blue is 5 out of 21. Now let's multiply them. And I get 210 over 10,626. And the question is asking for 4 decimal places. So I take 210 divided by 10,626 and I get 0.0198. Question C, I want to find the probability that all 3 marbles are green. Again, the probability that all 3 marbles are green equals the probability that the first one is green multiplying by the probability that the second one is green and multiplying by the probability that the third one is green. There are 11 green marbles out of 23 total marbles. So the first draw is 11 out of 23. After the first draw, 1 green is removed. So the second draw is 10 out of 22. Now the second green is removed. So the third draw will be 9 out of 21. Now let's multiply them. And I get 990 over 10,626. And the question also asks for 4 decimal places. So I take 990 divided by 10,626. And I get 0.0932. Now, let's move to a question that combines several probabilities. Part D. I want to find the probability that all 3 marbles are the same color. Let's think carefully about what this means. There are 3 ways this can happen: all red, or all blue, or all green. So now, this is the probability involving OR. We are going to add the probabilities. We are going to take the probability of all red plus the probability of all blue plus the probability of all green. And these 3 probabilities were found in part A, B, and C. We just need to replace them. This is the probability of all red. This is the probability of all blue, and this is the probability of all green. Now, instead of using these decimals for the calculation in part D, I will use these fractions. Because these decimals are being rounded, they are not exact value anymore. Whenever you want to use a number for further calculation, always prefer using the exact value. So the probability of all red is 60 over 10,626. The probability of all blue is 210 over 10,626. And the probability of all green is 990 over 10,626. Now, I need to add these three fractions. 60 plus 210 plus 990 is 1,260. And 1,260 divided by 10,626 is 0.1186. Part E. Find the probability that none of the three marbles are green. Let's think about what none are green means. If a marble is not green, then it must be either red or blue. Now, we want the probability that the first one is not green, multiplying by the probability that the second one is not green, multiplying by the probability that the third one is not green. There are a total of 23 marbles in this jar, 11 green marbles, 7 blue marbles, and 5 red marbles. If the marble is not green, then it must be either blue or red. So there are a total of 12 non-green marbles. The probability that the first marble is not green is 12 out of 23. After the first draw, one of the non-green marble is removed. It doesn't matter red or blue, just one of them. Now, there are 11 non-green marbles left out of a total of 22 marbles. To find the probability that the second marble is not green, we take 11 divided by 22. After the second draw, another non-green marble is removed. There are 10 non-green marbles left out of 21 marbles total. So the probability that the third one is not green is 10 out of 21. Now, let's multiply them. 12 times 11 times 10 is 1,320. 23 times 22 times 21 is 10,626. And the question is asking for a decimal rounded to 4 decimal places. So we'll take 1320 divided by 10,626 and we'll get 0.1242.